Okay, today we're going to be solving systems of equations by elimination. Last class we talked about substitution, and the rule with substitution was that one of the equations needed to be either y equals or x equals to be the substitutor equation. And you can see in this example here that we do not have that. Instead, both of the equations are written in standard form. Standard form means that we have the x's and y's on one side, and we have the plain number on the other side. So we have a column of x's, a column of y's, and a column of plain numbers. So that's going to be our clue that we want to use the elimination method. The word eliminate means go away, and that is what we want to do with one of our variables. So what we're looking for is we're either going to look for the x's or the y's to go away if we add them together. If we take a look at our x's right now, we have a 2x and a negative 2x. If I add those together, 2 plus negative 2 is 0, so they would go away. And that's what I want. So some other examples where that would work would be if I had 7x and negative 7x, 9y and negative 9y, 3x and negative 3x. Okay, we can eliminate x's or y's. It doesn't matter which one. It just kind of depends on the equation and what looks like it's going to be easiest. All right, so since we do have our x's ready to eliminate, we can start this right away. So we're going to add the columns. So I'm going to add 2x and negative 2x, and those will cancel out. I'm going to add my y's now. 3y and 6y is 9y. Bring down the equal sign. 4 and 14, we get 18. And now we have an equation that only has one variable, which means we can solve. Divide by 9 on both sides. Y equals 2. And I forgot to do something from the beginning that we've talked about, and that was knowing that we are solving a system. I should have, at the beginning, made myself a little answer blank. And that's going to help remind me that right now I do have the 2 to put in for my y value, but I'm not done because I don't have an x value. So in order to find our x value, we're going to plug that 2 back into one of the original equations. It doesn't matter which one you pick, so we can pick this one, that's our first equation, or our second equation. It doesn't matter here, both of them are similar. I'm going to pick the top one because they have slightly lower numbers, so I like that. So we've got 2x plus 3y equals 4, and I'm going to take this y equals 2 and plug it in. Keep solving. Now I only have x, so I'm going to be able to solve here. I'm going to minus 6 on both sides. I'm out of room, so I'm just going to move over here. When I minus 6 on both sides, I get negative 2. Divide by 2, we get negative 1. Okay, so we have our answer, negative 1, 2. Okay, something some people ask sometimes is, that seemed pretty easy. That 2x and that negative 2x were already set up to be able to eliminate, and that seems a little bit too convenient. And that's true. It's not always going to be set up to perfectly eliminate. So on our second example here, make sure you're writing this down as we go. We have to decide our x's or y's for our elimination. So I'm going to take a look at my x's first. Right now they cannot eliminate. They are not opposites of each other. I look at the bigger one, which is 6x. So if that's 6x, I have to look at what I want my second one to be, which would be a negative 6x. Okay, how would I make this be a negative 6x? And the answer would be multiply it by negative 2. Okay, so that's one option. I can multiply by negative 2. Okay, but then I can also look at my y's. Maybe it's easier to do the y's. When I look here, if I look at my bigger one of negative 5, I look back at 2y and I think, okay, could I make that be a negative 5? And I can't. I can't multiply by, actually it would be a positive 5. There's nothing I can multiply by that would work there. So I would end up having to multiply both equations. And right away I know with my blue ones, with the x's, I would only have to multiply by 1, so I'm going to pick that. Okay, so we're going to go back here, and I have chosen to multiply my first equation, all of it by -2. Make sure you use parentheses. We put that -2 in front. We are going to distribute to every single part. And that creates my new equation, -6x minus 4y equals -8. Okay, my second equation doesn't change at all, but I do want to rewrite it because I want to have my columns stacked. All right, so now we are ready to go ahead and add. We look at our x's. We've got -6x plus 6x. Those are going to eliminate. And that's what I wanted, so we feel comfortable with that. Now we can go on to our next column. -4y plus -5y is -9y. And our last column, -8 plus -1 is -9. And now I've got a nice equation to solve. Divide by -9 on both sides. Y equals 1. Okay, here is my answer blank. It's a point. I have the 1. So I need to plug that back in. I can choose either of the original equations. I'm just going to choose the first one. So we've got 3, let me pick a different color. 3x plus 2y equals 4. And I am going to substitute 1 into that. Okay, trying to get x alone here. Now when I divide by 3, I do get x equals 2/3. I know that's a fraction, but that's okay. We don't have to do anything with that, so it's not like we're going to have to do any adding or subtracting with the fractions. It's also a nice fraction on systems of equations. Sometimes we will have nice fractions, 2/3, 1/2, 1/4. But if you get it like an uglier fraction, like 37/52, that wouldn't be something we're usually going to make systems turn out to be. So that would be a good clue for you to check your work. Okay, looking at our last one here. We have to decide which one to eliminate, so I'm going to look at my x's first. You look at the bigger number, which is 5. Could I make 2 into 5? There's nothing I can multiply to do that. So that means I'm going to multiply both of them up. And the way that we figure out what we're going to multiply is we can just multiply the 2 together. 2 times 5 is 10. So my goal is going to be to get both of the x's to be a 10x and a -10x. My other option is to eliminate the y's. Okay, now 3 and 4 gives me 12. So I need to multiply the top equation by 4 and the bottom equation by 3. So either one is fine. In the y's, the blue ones, we do already have a negative, so that's nice. Some people might say I'd rather choose the x's because I like multiplying by 2's and 5's. I'm going to choose to eliminate y's here because we eliminated x's in both of our other examples, and I want to be sure that you see we can do either one. So I'm choosing to eliminate the y's, which means I'm going to multiply up to get 12. So this first equation, I am multiplying by 4, and my second equation, I'm multiplying by 3. Okay, this becomes 8x plus 12y equals 32. And this becomes 15x minus 12y equals -9. All right, let's add up our columns. 8x and 15x is 23x. 12y and -12y eliminates, which is what I wanted. 32 and -9 is 23. Divide by 23 on both sides, x equals 1. Alright, so I've got my x equals, but I need my y equals. I'm going to plug into either of my two equations. So I'm taking this equation, 2x plus 3y equals 8, and I'm going to plug x equals 1 in. solving here. Y equals 2. All right, please make sure you have those in your notes. If you need to rewind the video to copy anything else down, I will be checking these notes next time I see you. You should have all 3 examples completed.